to Menora Academy by Pastor O.O. Kenneth. And of course, this is the place where mathematics is made easy. Always like, subscribe. It doesn't bite. Subscribe. Subscribe. And always reach out to me if you need one-on-one coaching. I'm always there to put you through. Alright, so we make impact globally. This place has helped and produced a lot of people. Alright, now look at this. Today we'll be continuing with some of terms in AEJP. On this is sequence and series. We have done AP, some of terms in AP. We have done GP, and then a number of terms in GP, and then we are now in some of terms in GP. So you can go and watch all those videos. It's in series by series, so just always watch them. All right, now look at this very well. To solve some of terms in AP, you will agree with me that your xn, now this is the formula. We have two formulas to solve. Right? They are similar, quite similar. So the question, the pattern in which the question comes, we determine how you are going to solve the questions, or the formula you are going to use rather. Now our Sn is equal to a into bracket of r raised to the power of n, and then minus 1. All over r minus what? Minus 1. If you can use this formula, r will come first if r is greater than 1. So if they give you a question and then r is greater than 1, the value of r is greater than 1, then you use this formula. Then Sn is also equal to a, and this time around 1 comes first. So if r is less than 1, then you are going to use this particular formula. So we are going to see how we are going to apply this formula very fast. Now question number 1, the fifth term of an exponential sequence is this, the 4375, and the second term is 35. Find the sum of the first 5 terms. Alright, so we are going to be solving this question together very fast. Alright, now look at this question. Question number 1. They said the fifth term, so t of n is given to be t of 5 is given to be what? Is given to be 4375, and then and then the second term, so I mean t of 2 is given to be 35. Then find the sum. Before we find the sum, remember we need to find the common difference, the ratio rather, the common ratio, and our a. So we are going to be solving this question simultaneously to find our a and r. Now, using the number of terms, the n term of GPs is going to be t of n equals to, before we use this formula, we need to use this formula, n term of GP first, which is what? AR raised to the power of n minus 1. So now this is going to be, first of all, t of 5. T of 5 is going to be equals to AR raised to the power of 5 and then minus 1. And this t of 5 is given to be what? Is given to be 4375. So if this is the case, now forget about the left hand side. We are going to focus here, which is AR. 5 minus 1 is 4, which is going to be equals to 4375. So we call this equation 1. And then also our t of 2 is given. T of 2 will be equals to AR raised to the power of 2 minus 1, which is t of 2 is given to be 35. Lift the left hand side alone. We have r raised to the power, this minus this become 1. So we have 1r there to be equal to 35. This is going to be equation 2. So now we are going to divide equation 2 by equation 1 by equation 2. Divide equation 1 by equation 2. So we are going to, our equation 1 is what? AR4, a raised to the power 4, to be equals to 4375, because the value is higher. So we use it first to divide with the value that is lesser, which is going to be equals to 35. So a will cancel a. So one of the r here, according to law of indices, is going to be 4 minus, there is 1 here as a power, so 4 minus 1, which is equal to 4375. 4375 minus divided by 35 rather. So it's going to be 125. Now that we have 125, this r 4 minus 1 is what? Is 3, what equals to 125. So our r will be equals to cube of cube root of 125, and then cube root of 125, cube root of 125 is 5, equals to 5. So our A is 5. So we put 5 for R in equation. We can use equation 2. Equation 2, you can use any equation of your choice. Alright, so our equation 2, this is our equation 2. So our equation 2 is AR equals to what? 35. So our A, it will be A times our R. We've gotten our R to be 5, which is going to be what? 35. So this is 5A equals to what? 35. So our A now will be equals to 35 all over 5, which is equals to 35 divided by 5 will give us 7. So our A is what? Is 7. Now that we've gotten our A, remember our R is what? Is 5, and our A is 7. Remember this R is greater than 1. So if it is greater than 1, we are going to use this first formula. So our Sn is equals to A into bracket of R raised to power n minus 1 close bracket all over R minus 1. Alright, so because our R is greater than, the value of R is greater than what? 1. So the question says we should find the sum of the first 5. First 5, which is x of 6, will be first 5 x of what? X of 5, which is going to be equals to our A, which is the first term, is given to be 7. That is, this is 7, our 7 into bracket of our R is what? Our R is given to be 5 raised to power 5, because our n2 is 5. Then minus 1 all in bracket, all divided by our R. Our R is 5 minus 1. So now our x of 5 will now be equals to, this is 7 into bracket of 5 raised to power of 5 minus 1. 5 raised to power 5. 5 raised to power of 5 minus 1 is going to give us 3, 1, 2, 4. Alright, all over 5 minus 1 is what? Is 4. So now we are going to have, this is going to be equals to 7 times this value, 7 times 3, 1, 3, 1, 2, 4 is going to give us 9, 7, 5, 9, that's 9 million. Then also we have 3, 7, 6 is going to give us this, all divided by 4. If you divide it by 4, you are going to have 2 million, and then 439,000, then 84400. Now this is what you are going to get as your sum. We've gotten our sum. Then question number 2, very fast. The question says the third term of a GP is 63, while its fifth term is 567. What is the sum of its first 7 terms? So we are solving simultaneously again. Now, from that question, we have our t of 3, which is the third term, is given to be 63, and then also while the fifth term is given, t of 5 is also given. T of 5 is given to be 5, 6, 7, and then before then we are going to find our A, and we are going to find our R. Now remember, t of n under GP is AR raised to power n minus 1. So t of 3 first. T of 3 will be A raised to power 3 minus 1, which is given to be what? To be 63. Leave the left hand side, we have A raised to power this minus this is 2, which is equal to what? 63. Now that we have this, we are going to target equation 1. Also our t of 5 now will be equals to what? AR raised to power 5 minus 1, and then t of 5 is given to be 5, 6, 7. Now that we have 5, 6, 7, leave the left hand side alone. We have R raised to power 5 minus 1 is 4, so be equals to 5, 6, 7. Now that we have 5, 6, 7, now we are going to have equation 2. So now in this equation 2, from this equation 2 now, what you are going to do now is that you divide. The value of equation 2 is bigger than this, so divide equation 2 by divide. You're going to have divide equation 2 by 1. Alright, so our equation 2, we have a raised to the power 4, which is equals to 567. Then our equation 1 is ar raised to the power 2, all over the equal side is 63. So a, we cancel a, so r raised to the power 4 according to law of indices minus 2, which is equals to 567. 567 divided by 63 will give us 9. So r raised to the power 4 minus this is 4 minus 2 is what is 2, which is equals to 9. Now that we've gotten this particular value, that value now, therefore our r will be equals to square root of 9. Square root of 9, which is equals to what? 3. We've gotten our r to be 3. Remember this r, which is 3, is greater than what? It's still greater than 1. So we put 9 for r in equation. You can use any equation of your choice. I'm using equation 1. So my let me clean this place. So we are going to be substituting very fast. Alright, so now our equation 1 is this. Equation 1 is ar squared equals to ar squared equals to 63. This is our equation 1. So it's going to be a times our r is found to be 3 already. 3 squared, which is 63. So this is a times 3 squared is what is 9, which is equals to 63. So this is going to give us 9a equals to 63. So therefore our a will be equals to 63 divided by 9. So 63 divided by 9, 63 divided by 9 will give us 7. So our a is given to be 7. Now we'll find it to be 7. No, so let's go get back to the question properly. The question says, what is the sum of its first 7 terms? So we are asked to find x of what? Of 7. So x of n is equals to a into bracket of, remember our r is greater than what? Is greater than 1. So because it's greater than 1, always take note of that. We are going to be using this. So which is what? There are cases that is less than 1, so you use this first, alright? Now, so this is going to be r raised to the power n minus 1, close your bracket, all over r minus 1. So our x of 7 will be equals to, our a is given to be what? To be 7 into bracket of our r. R is what? Our r is 3. So 3 raised to the power of what? N is 7, then minus 1, close your bracket, all over 7. Our x is 3 minus what? 2. So this is going to be equals to 7 into bracket of 3 raised to the power 7 minus 9 minus 1. 3 raised to the power 7 minus 1 is going to give us 2186. Close your bracket. The 3 minus this is 1 rather. 3 minus 1 is what? Is 2. So now this is going to be equal to 7 times 2186. 7 times 2186 is going to give us 15,302. So this is over 2. By the time you divide it by 2, you are going to get 7,651, and that is the sum. That is the sum. Thank you for watching to the end. This is Menora Academy. Always like, always share. God bless you.